Good morning, my dear. Good afternoon, my dear kids. In today's class, in the chapter kinematics, we are going to discuss the different rain umbrella concept and the cat dog moving. How to describe the motion of cat with respect to dog? These are the two topics what I have picked up. So let's try to explore the maximum theory and the numericals also. Okay, fine. So let me start it.
Sir,
Yeah.
this balloon rain umbrella problems are from relative velocity, right?
Yes, yes, it's there. It's there. Listen happily. Everything relative motion concept. Okay. First we will take the, so let's have the, if there's a dog, I have to draw the dog. I said dog only, not any other animal. What happened? Okay, let this be dog. And the, okay, let this be cat. Okay, there's a dog, there's a cat. It is moving with, say, like a 3 meter per second. This is moving with 4 meter per second. So what are the 3 meter, 4 meter per second? Velocity of dog along x-axis, it is the velocity of dog along x-axis, it is 3 meter per second. That of the cat, it is 4 meter per second. Now the same cat, okay, if it looks at the dog, how do it will feel in what direction it is moving? Or if the dog looks at the cat, how do it will feel moving? I think this particular thing you can experience when you are taking turn. Like when you're going in a vehicle, when you're taking turn, when you look at the road, you feel you are moving in one direction. When you look at the vehicle coming from other side, you are the left or right hand side of the road, then you feel you are moving in different direction. This you can experience. It's not that something imaginary. So now what is the velocity of cat? It is equal to 4 j cap meter per second. Velocity of dog, it is equal to 3 I cap meter per second. So these are the, so what are this? Velocity of cat with respect to ground. Similarly, velocity of dog with respect to ground. Now what is the velocity of cat with respect to dog? I'll go for simple relative velocity, Vc minus Vd. I think there's a general formula. The whole week I'll be using this formula. That's all. The whole week it's all about using this formula. Any concept will be using this one. The application of this is what the whole week just revolves around this one. Velocity of cat is how much? 4 j cap. Velocity of dog is how much? Plus 3 I cap. Substitute all this with sign. Okay, they are moving along positive x and y axis. So this will become minus 3 I cap plus 4 j cap. Means when cat looks at the road, it feels that it's moving along y axis or the north, you can put it. Dog, when it looks at the road, it feels that it is moving along. It is moving along x-axis. But the same dog, when it looks at the cat, how did it feel? When the same cat looks at the dog, how it will move? Now you have this velocity minus 3 I cap plus 4 j cap. So where do this vector lies in the second quadrant? So this is the velocity I'm getting. So in this direction, it appears to be moving. And with what speed? So VCD is equal to root of minus 3 whole square plus 4 whole square. So this will be 9 plus 16, 5 meter per second. So this is the VCD. Actually, cat is moving along north, but when it looks at the dog, it feels it is moving in this direction. I think cat will feel happy, no? That I'm moving away from him. That too with more speed. Then what is the velocity of dog with respect to cat? It should be negative of this vector, minus 3i cap plus 4j cap. So this will become 3i cap minus 4j cap. I think it is exactly opposite of the other vector. The dog will not feel happy, no? I'm moving away from cat. So this is the relative motion. It appears like this. So what is this angle? Can we find out anything angle? What angle the motion is? So this will be tan theta. Tan theta is equal to x component is how much? 3 by 4. So it will make an angle 3 by 4 with its original direction. So now still okay. Let's talk about the we know some vectors. No, the idea of vectors will bring into the picture. Huh? The idea of vectors will bring into picture. So let's take the vector diagram. VC bar is here, and this is VD bar. Okay. Now VCD bar I need it. So for that, what shall I do? I'm going to take this minus of VD bar. This is very important. We must bring this vector diagram in almost all the problems. Then I'll shift either VC or VD bar, anything. Okay, let me shift the VC bar. The resultant vector is something here. This is VCD bar, no? Okay, look at that. The same thing which I drew there. This one. So VCD bar is in this direction, no? This is what we are getting. Now, similarly, sir, like can you show VDC bar in the vector diagram? See, vector diagram, this is about the mathematics. I think will be more safer side if we have some sort of vector diagram like this. Then similarly, I want VDC bar. In that case, what shall I do? I'll keep VD as it is. Minus VC bar, I'll bring it here. This minus VC bar, I'm going to shift it. The resultant vector, something. With what speed? What is the speed of the cat with respect to dog, or speed of the dog with respect 5 meter per second? So we'll write that comment here. Speed of dog with respect to cat, or speed of cat with respect to dog is 5 meter per second. Now, what is this arrow? Say something. See, everything is fine. These are all mathematics, but we want more about our physics things should come into picture. When cat looks at the dog, it feels that it is moving along this direction. That is the meaning of that arrow. So, what is this arrow? When cat looks at dog, it feels it is moving along VCD bar along this direction. I think these comments are very important. Something, what is the meaning of that, we are able to put it here. Similarly, when dog looks at cat, I don't have place. When dog looks at cat, it feels it is moving along this direction. Okay, are you getting? So it's all about the vector diagram. A student has to take help of this. Is what I feel very important. A student has to put effort in learning through vector diagram. It will be very easy because there the mere mathematics, this will not help you much. Of course, 3i cap minus 4j cap. The diagrams will help you. Oh, in this direction, the cat, when cat looks at the dog, it feels it is moving like this. Then bring it here and express. Are you getting? No, you have to understand things here. One problem is enough. I'm telling this one problem. Like anything of this kind you can manage. Again, the rain umbrella, the core idea, you can manage anything. River boat, you can manage anything. Aircraft wind, again the similar situation. Relative projectile motion, I think. So I say that there are 10 ideas are there all together this week. Based on the 10 ideas, you are having another 10 into 10 you multiply. 100 numericals are there. But the 10 ideas is the core central. With that you can manage most of the numericals. Drawing triangles is very important. Yeah, scribble it first. I'll scroll down. I'll really help you a lot. Need not to bother, but you have to put at least some effort. You have to understand at least the basic thing: vectors, triangle, vector subtraction. What do you mean by negative of vector? Minimum those things. If you can apply it here, that is enough. You can get through this whole 1 week. We will shade this. And now if let's take the one more numerical. We'll take some cars, car A, car B, like that. Huh? So this is a road. I'll give a better description. This naturally for when you are moving in a car, this I think you do experience. This is a car A. This is a car A, this is a car B. Now, so when car A is moving with 3 meter per second, that we know it. Okay, these are the roads. I think junction. Now, in what action, when car A looks at car B, it feels that it is moving with certain speed. Okay, or else I'll give one problem. When car A looks at car B, with what speed he feels is moving, and in what direction he feels is moving. Now they are, earlier they are moving, no, now they are approaching. What is VA VB? Velocity of cars A and B with respect to road. Then when car A looks at car B, in what direction it will feel. So here we'll take these are the roads. This is a junction. They're approaching a junction. Now VAB bar equal to VA bar minus VB bar. VA bar 3I cap minus 4J cap.
Sir, 4 or 5, sir?
What I wrote 5. Yeah, I'll make 5. So this will become 3I cap plus 5J cap meter per second. Then what is the speed of car A with respect to B will be 3 square plus 5 square. 25 plus 9 root 34 meter per second. What about the angle? All that will show in the vector diagram. VAB is something, it is telling 34. So when A looks at the junction, he feels it's going straight. Or say like here northeast will bring it, because I cap J cap there I took it. Here northeast. Some problem they'll ask like this only. Car B is heading towards south. Car A is heading towards east. When car A looks at B, in what direction he feels moving? He feels that he is moving along, so like a northeast. Are you getting? Now look at the 3I cap plus 5J cap, something northeast, and definitely it will make some angle also. If you look at this, it will 3 5. So tan theta equal to 5 by 3. So then what is the velocity of car A VAB bar? How do we can express? Instead of vector, we can also go for root 34 tan inverse of 5 by 3 north of east. I think you must be aware of expressing directions like this also. It will make an angle theta with east. Sir, can you show VAB bar here? Yes, VAB bar will be somewhere in this direction. This theta we are measuring with respect to east, but you have to read it as north of east. I think suddenly you feel you are looking at junction, you feel okay, no problem. But when you look at the car, what happen? You feel you are approaching it and you may collide. I think you will be extra alert, no? So next time when you are moving in vehicle, that if you are sitting on the front seat, I think you can do experiments. Please do make observation. You have to make observation. There is no other way. Most of the things, kinematics, no, it's a very generalized one. When B looks at A, so instead of this, we have to show it here. Actually, what is the correct thing? This is only for your understanding. Here is what we have to show it. The vector that has to be shown at this particular. Here we have to show it. This is what VAB bar. Are you able to understand now? So immediately you feel you are going to collide with that. So what you do? You are moving with high speed, you will further decrease, or you may put a brake. All such things happen, especially at the junction. Similarly, if B looks at A, I think it's quite simple, no? VBA bar equal to minus of VAB bar. This should be minus of 3I cap 5J cap. Exactly opposite to this. The vector should be directed exactly opposite to that. It's all about vectors. Application of vectors is what we are going to do here. So what is that red color arrow? The direction in which car A feels it's moving. That one. So what is VA bar? The direction in which he feels that with respect to when the driver of the car looks at the road, he feels that he is moving along this direction. See what happened in books. Everything is fine. What do you mean by VAB bar? What do you mean by VA bar? Okay, they just have put a statement assuming that students knows all these general things. Student knows all these general things, so why to unnecessarily write so much of paragraphs? So here what is this VAB bar and VAB bar? Anything shall we call this as direction in which car A is moving when driver looks at road. When he looks at the road, he feels it's moving. So no, what about this direction this part I feel very important. Understanding has to come up to this level. A direction in which car A is moving when driver looks at car B. Agreed. This is a very fundamental. I want students to put some effort in accepting such things. Imagine. So every problem you have to put an effort of this kind. You have to put effort. If you put effort, it'll come. Things will be there. What is there in that one? You have to understand. Oh, this is what happening. Then go for take help of maths and conclude the answer. It will be a test later part. VAB bar, VA bar, because when you move with the velocity VAB bar, the car B will appear a test, and you are going to go and collide with that one. If you move with the velocity VAB bar, what will happen to car B? Car B will appear a test. Sir, but car B is moving. As person of car A, when he looks at car B, no, definitely what happens, you feel that S, like it's moving with a velocity VAB, and car B will appear at rest. Similarly, the person B, when it will appear, when you start moving with a velocity VAB bar along this direction. You are moving like this only, so no question of that. When you move, when the car B should move like this only. When car A, instead of moving like this, if it moves along this line with a velocity VAB, then it will appear at rest. I don't think so anybody will leave road and go like that. Nothing, no. Rahul, did you got it, my point?
Yes, sir.
That's the meaning, like a don't appear like a when car A moves along VAB bar with a velocity VAB bar with a speed VAB bar, then it will appear at rest. That will do in the next coming topics. So what is this VAB be? VAB, what you should call speed of car A with respect to car B. Now here only some small like we'll take example, then we'll move into rain umbrella concept. Will become very easy for you. Completed. Okay, we'll take the next example. Suppose say here there's a body 1, particle 1. Next, the other particle is moving like this. So I want V1 2 bar in what action? Let's go for some vector diagram. This is V1 bar. This part is the V2 bar. Then the resultant V12 bar, red color. Resultant V12 bar, we'll see in what direction it will be. So this will be V1 bar. This is V2 bar, and this is V12 bar. Okay, agreed. I think we know how to calculate V12. V12 is equal to V1 square plus V2 square. V1 square plus V2 square. What about the angle? As we can define angle. Now, by chance, if speed of car 1 increases, anything will happen to V12 bar? Means when car 1 looks at the road, he feels he's moving along east. When he looks at the 2, how you feel is moving? Minus, okay. Some correction is there. Wait, here. V1 bar. This will be minus V2 bar. Then V1 bar minus V2 bar is needed. So we will shift this. So V1 bar minus V2 bar. The resultant vector will be somewhere here. Just some correction. V2 bar minus V1 bar, no? So V1 bar minus V2 bar. V12 bar means. Okay, this one. So when car A looks at car B, it feels it's moving now in this direction. Now if a car A increases, anything will happen to this theta, anything will happen to this V12. If he increases speed, then V12 should change. Simple maths. And what is tan theta? Or we define tan theta? Tan theta equal to V2 by V1. So if he increases V1, definitely this theta has to decrease. So if he increases V1 means just the length of this vector shall increase. Now similarly, I'll put like V1 dash. This is very important in the entire relative motion. Taking help of this concept of like this will be really going to help a student a lot. Okay, the same thing now the particle 1, it doubles its speed. V1 dash, I'll write it. The particle 2 as usual it will continue to move. Now V1 dash is 2 times of V1. Anything will happen to the direction in which he feels is moving when he looks at the 2. Particle 1 looks at 2. It's very simple, no? So if this doubles, then what we should in this triangle also, I should increase the length of vector. Then this will become V1 dash, V2 bar. V1 dash. Then I'll go for the resultant triangle. V12 dash, I'll write it, or some prime or some symbol. This angle has to change, no? It's quite simple. Forget about all this. You know, triangle you have drawn in high school. If you increase the length of this triangle, anything will happen to this diagonal. Hypotenuse, its direction should change and also length should change. That's all. So if we double the speed, then what will happen to him? He will start moving. He feels that he is moving in now the separate direction. Earlier he feels that he was moving like this. Now if we double the speed, now he feels that he is moving in this direction. This was the.
I have a small doubt, sir.
Wait. Your doubts will come later.
It's only about the diagram, sir. The above diagram. The first triangle. There you wrote the one head and one tail is joining, sir. But the V2 should be the other side, no sir? According to the graph.
Minus V2 bar, my dear.
Yes sir, minus V2 bar, but V2 and V1 tail should meet, no sir, but tail and head are meeting.
Whose side? Whatever you want, you cannot imagine. No, I'm just adding two vectors, tail, head, tail, head. I'm shifting this vector. No, tail, tail is there. Can't I shift this? We have done so many problems in vectors. Huh?
Sir,
We have done so many
you
problems.
could
We have shifted
parallel
this vector.
them,
Huh?
sir. You could parallel them, I forgot.
Okay, we have done so many things. No, see, you have to put effort. You have to recollect. No, you can't forget everything and come to the class with empty mind. How it is possible? Huh? Okay, no, this I'm just shifting it. So there's a bar, there's a b bar. Okay, there's a triangle of vector addition, tail head, tail head. The resultant should be from tail of first vector to head of second vector. Now, if you increase the speed of, if this particle increases its speed, definitely the length of this vector will increase. Say in this triangle, what we should do? Just increase the length. Then definitely the resultant, its orientation and the length also will change. It's a very simple idea. So now, what is v12 dash prime or anything what you can call? It's quite obvious, no? The okay, now see, like if this v1, if this increase, this has to change, then even this orientation also change. So now if we double the speed, will he feels he's moving in same direction when looks at 2? No, some other way here. So here we have to put that vector, resultant vector, how it will be. In the first case, this way of thinking is very important. That's why I've just brought it for discussion. Than struggling in numericals, a student has to develop this method. Shivani, you have to mute it, ma. Huh? What do you mean by that V12? Particle 1 looks at the ground, he feels he's moving along x-axis. When he looks at 2, he feels that he's moving in this direction. Similarly, particle 1 is moving along x-axis. Now he has double the speed. Let's assume that one. Now, when he looks at the ground, he feels he continues to be in same direction. He feels that I'm moving along it. But when he looks at 2, no, he feels now he is moving it with some different speed and with at different orientation. So it's quite very simple. So you have to take help of vectors here. This is very important, vector diagram. If this length of this vector increases, definitely this length and also its orientation will change. So the direction in which one moves with respect to 2 has to change. That's what we are concluding here. The whole relative motion now just revolves around this idea. The drawing vector diagram and analyzing it. Triangle of vector addition. Everyone should revise. All forgotten, at least revise. At least for tomorrow's class, you revise and come. I feel like these are the essentials. With this, you can manage the complete relative motion. The whole week you can manage. Sir, what is the methodology you tell me? VAB bar equal to VA bar minus VB bar. Apply that formula. Because I think everywhere I'm using that one only here. Nothing big. Okay, we'll take the rain umbrella concept. Hello, Habish Tiaran. I told you no. I'm going to discuss paper. Why you are troubling me with this so many times and all? I'm going to discuss paper. You don't have faith on your teacher? Rain umbrella concept. Till I had to finish off this topic. At the end, I'll go for paper discussion. I think 4:30. After 4:30, we'll have a paper discussion. Okay. Let's come for this one. A person standing on a road.
Sir, but we have maths class from 9 o'clock.
Okay, at 4 to 5 we'll make it. Huh?
Okay, sir.
By 4 we'll cover the concepts.
Okay, sir.
Yeah. Okay, now this is the person. A rain is falling vertically. Very simple concept you can manage. Let me take the velocity of rain, 10 meter per second. Then it should not get wet, no? So definitely what you'll do is going to bring an umbrella. Okay, this will be this umbrella. You will go for umbrella. You'll open the umbrella. That definitely will protect. No, I think the umbrella should be of certain size where it should not get wet. I think that also matters. We'll not. Let's not bother. We are just discussing only some small basic conditions here. So what should be the size of umbrella? Is it should be of sufficient size. You cannot go for very small size which will just cover only his small part of his head. Definitely will get wet. You should choose. He has chosen suitable size of umbrella. So rain is falling vertically and the person is at rest. Definitely how we should hold umbrella? He should hold against the VR bar. In what action the rain is happening? Against that, if he keeps umbrella, definitely open, he can protect himself from the wetting. No sir, he will not open umbrella. Then he'll get wet. We are doing this problem, it should not get wet. Sir, like is it really that useful? See, here we have brought rain umbrella. Actually this is useful for, if you just go back some 70 years or World War II, prior to that, the planes, what happened, they had a windshield. The windshield, it was cockpit was not covered. At the time, the effect of wind is something very, very, very important for them. And the windshield position, they have to adjust according to the wind, because the plane will be moving in one direction, the wind will flow, and the wind should not blow against the pilot, because it will be very uncomfortable. No, now we have helmets. If you just go back, no, the face was not covered. The wind coming with a high speed, striking your face, very big headache. So he has to adjust the windshield position, all that. So there, all these concepts were used. That we have converted to rain umbrella here. Otherwise, you walk in a rain. Who is bothered all these things? Means if you know this rain umbrella concept, then only you can walk in a rain with umbrella. Nothing, no. Just to explain that, we have brought it to rain umbrella here. So when the person is at rest, then the rain is falling vertically. So he should hold umbrella against the VR bar, not to get wet. Now the person definitely will start moving. The rain direction will not change. The rain will pour as it is vertically down. Okay, now the person. Now how we should hold umbrella? Now is going to walk with a speed. Velocity of man. Okay, this is the BM. Will write it. 10 meter per second. How we should hold umbrella? There's a question. So now we'll go for velocity of rain with respect to man. This one here. VRM bar equal to VR bar minus VM bar. VR bar is minus 10 J cap. This will be plus minus of plus 10 I cap. Yeah, we have to substitute all this sign. So this will become minus 10 I cap minus 10 j cap. So what is the speed of the raindrops? Vrm equal to minus 10 whole square ten root 2 meter per second. The actual what is Vr? What we should call Vr? Vr is actual velocity of rain with respect to ground. What is Vm? Velocity of man with respect to ground. What is Vrm? Velocity of rain with respect to man. So Vrm, what direction? I think I have a vector here. J cap minus 10 I cap minus 10 j cap. Somewhere in this direction it will come. So the rain drops now they start appearing in this direction. Now how you should hold umbrella against the raindrops, no? So the umbrella should be positioned in such a way that it should be against this one. So now he has to hold umbrella in this way.
At 90 minus theta with the horizontal.
Wait. Let me complete everything. I'll come it. Huh? He should hold his umbrella. He should hold umbrella in this way here. If you hold umbrella like this, yes, definitely. So theta is what with respect to vertical is what I assumed it. So how much you should make, or if you want, if let me take this is theta, then you should make it inclination theta with respect to vertical. So this will be the umbrella. So you should hold umbrella like this here. Now this is very important. Sir, how come rain falling? It will wet. I think there's something, sir, you are wrong. No, I'm correct. There's no problem with the person holding umbrella. The person has to hold the umbrella in this direction only. Then only you can avoid wetting. If it stops running, then immediately you should make the umbrella vertically up. If it starts running with a 10 meter per second, then you should tilt it. Then how much it should tilt? So you should tilt through an angle. So can we get that angle? I think this is theta. This is tilt. You should tilt this with at an angle. Can we calculate that theta? Okay, let's get into the calculation part here only. Let's draw the vector diagrams. This will be more important. Okay, there's the actual velocity of man, velocity of rain. These triangles are very important. Once again, we want velocity of rain with respect to man. So here minus Vm bar so then further what about the resultant? Vrm bar is going to come in this direction. Able to understand now? If this is theta, this will be theta. Now what is tan theta? We'll find out. Tan theta equal to Vm by Vr. 10 by 10, 1 degree. So what is theta? Theta will be 45 degrees. So how much it should tilt? It should tilt by 45 degrees with respect to vertical. It was earlier holding vertically. Now as it starts moving at 10 meter per second, it should tilt it by 45 degrees. Then you can avoid the wetting totally. But the rain is falling vertical. No, the Vrm is what now very important. The vector diagrams are very important. I'm requesting everyone put effort. Right, you can learn lot by these things. There it's a mere mathematics I cap j cap. The diagrams will help you a lot. Maybe man is in hurry. So what you'll do is like you will increase the speed. The rain is going to fall. The rain is going to continue in the same direction. So since if I move, what will happen? The rain direction will change nothing. The rain in what direction is actually falling? The same direction is going to continue. The man, what happen is going to double the speed. If we double the speed, any conditions will arise, we'll see it. Is in hurry, you will double the speed. Now is running with the speed earlier VM, no, VM 1, I'll write it. Let him double the speed. Then how we should hold umbrella, how much he should tilt. Then what is the speed of the raindrop with respect to man? Okay, what is this VRM bar? Speed of speed with which
You should tilt it a little bit more, sir.
yeah, wait. Work out happily. In the end, I'll conclude it. No, huh? Okay. Speed with which raindrops strike umbrella. Against VRM bar, always you are told umbrella, not to get wet. That's the basic idea. No, it's quite very simple. No, here the man he has doubled it. If you increase this length, definitely the length of this will increase, and even this orientation also will change. You know all of your triangles. If you just increase this length, definitely this hypotenuse length has to change. Its orientation will change. So he has to now increase. He has to change the orientation of umbrella. That's what we have to analyze here. Okay, now the vector diagram. We'll take the vector diagrams. So this is going to double it. Look at the, so why you increase this length? VRM1, I'll write it. So new this one. So now the orientation is more, definitely. Phi, is it more than theta? Yes, it has to be. Can we calculate? Yes, we can do that one. So first we'll calculate VRM1 bar is equal to VR bar minus VM1 bar. This is minus 10 J cap minus 20 I cap plus of 20 I cap, no, minus 20 I cap, or else I'll write one step. So what is VRM1? VRM1 magnitude will be 20 square plus 10 square. 500 10 root 5. With more speed they'll come and strike. So whatever that angle, I'm interested in that angle. So tan phi should be equal to VM1 by VR. VM1 20 by 10 2. I think definitely we'll look at the more than 45. The phi is greater than theta. I think 54 will come. Anybody just give me the value of phi. $63.4. Yeah, thanks Pranay. So earlier it was 45. Now how much it is? More than that. It should tilt more. So how the umbrella, the orientation of umbrella should be Where is arrow? This will be the phi. This is VRM bar. I'm giving some colors also, at least you can understand it. So here he has to make the angle of tilt will increase. He has to tilt it more. Sir, like, are you sure, sir, like rain will not wet him? Yes, I am very sure. For you to do all this experiment will be very difficult. Because the rain should fall vertically, first of all. The rain should fall vertically. Now some students, they are head bent. Sir, raindrops will come and strike. No, if you are at rest, they'll raindrops, so whether if you are at rest, they'll appear. The actual rain is it's raining vertically. As you start moving, the raindrops will appear for you. So they'll come and strike here. I think this it happens for you when you are going on bike, no, especially. Sometimes what happens, the rain is falling when you rest, the raindrops will strike your head. When you start moving, the raindrops will wet your front part of the body, no, the behind nothing. It'll be dry, and your sometimes head also will be dry. Only the front part will be wet, no. The reason is this one. You decrease speed again, the raindrops will strike your head. If you increase speed, the raindrops will come and strike here. Next time, so you have possibility of rain comes, no, and anyway there's a rainy season, so if you want you can try it once. So bike all not possible, at least in the rain you can start running, there you can feel the difference. So if you increase speed, definitely the speed with the raindrops will strike you will also increase. Am I right? I think when you're going on bike, that too you feel it's raining, as you increase speed, what happens? They'll come with more speed and strike you, no? Then again you decrease speed. Actually the rain with what speed is raining, it's raining that one only. Because of your variation of speed, you feel that raindrops are coming with a different speed and striking you. When you increase speed, they'll come and strike with more speed. If you decrease speed, they'll come and strike with less speed. When you are at rest, the raindrops will strike with actual speed. This is what happens here. Agreed? So this is, I think, very generalized discussion. Huh? Okay, write it down. Anyone having doubts, you can clarify now. Huh? I don't think so. Everyone knows triangle, and everyone knows tan theta, and everyone knows relative velocity, VA bar minus VB bar. More than this, nothing is needed. So what is the basic necessity condition? The man, here we'll write that condition. The man should hold umbrella against VRM bar for not to get wet or to avoid wetting or drenched. Drenched means when heavy rain comes, no, there we use word drenching. So technically even that also can be brought, just be careful. To avoid wetting, the umbrella should be held against the VRM bar.
Sir, here we are assuming that there is no wind in any direction.
Nothing, man, there's no wind. Effect of wind, again the rain direction will change, no?
Yes, sir.
Yeah. Yes, yeah. Quite easy, all these things. Only thing is you have to just put some effort. Nothing is there. The basics of vectors is what should be. If you apply properly, you can manage.
Sir, maximum at what angle rain can hit the umbrellas?
What do you mean by that?
Sir, like if we move more than more speed, sir, like more than 20 meters per second, and what will be the max, sir, practically?
Practical, that depends upon the conditions there. No, you can't ask like this. What is the max, everything, that one. The raindrops will not come vertically down, not possible, no, like this.
Yes, sir, that's not possible.
Yeah. Huh? Okay, write it down fast. We'll discuss few more cases. No, still some students are like, I feel the raindrops will come and strike his head. No. If they test, they'll fall vertically. If they're moving, they'll come at an angle.
Sir, is there any condition in which we have to hold our umbrella at 90 degrees?
Wait for it. You can't ask generalized questions. I'll keep on examples. Wait for it.
Okay, sir. Okay.
All adding, deleting numbers, you have to contact admins. Please don't trouble me. I'm not related. I'm not academic principal something. Anything you have to contact admins only. It's not my job. Huh? After this, we have to. Okay, now I'll bring another situation. Let me move up a little bit. The person is at rest. The rain is coming from behind. Making 30 degrees. There's a velocity of rain 10 meter per second. Now the person is at rest. So how we should hold umbrella? So definitely I think umbrella will come here. Okay, you'll hold umbrella, something like this. No.
Sir, man is at rest, sir.
Wait, I'll explain everything, no? Why so much of hurry, everyone? Huh? Okay, there's a man, when he's at rest, then he has to hold umbrella against a VR bar, no? It is like this. So let me now, second situation, I'll bring it. Now he will start walking with a speed. He will start running with a speed Vm. Then how we should do umbrella? First case, we'll put Vm equal to 10 meter per second. Let's see that. We'll discuss here only. Now we'll increase speed. Then then we see that for certain speed you have to hold umbrella vertically. Then what is that speed? We'll calculate. Then here. We have to directly jump into the concept of VRM bar. So first, what is VR bar? We'll define it. VR bar will be 10 sine 30 degree I cap, 10 cos 30 degree J cap. So this will be 5 I cap. Phi root 3 J cap. This is the velocity of rain with respect to ground. Now you see that velocity of rain with respect to man will calculate. So VR bar minus VRM bar. Phi I cap, phi root 3 J cap minus of Vm bar. Vm bar is 10 I cap. 5 minus 10 will be minus 5 I cap 5 root 3 by 2 G cap. Look at him, like a VRM bar. It is making now somewhere in the third quadrant. So let's go for the vector diagram. We'll get a better picture. So this is VR bar. And this is a VR bar, no? Okay, the length is also same. This is VR bar. Minus Vm bar will come in the direction. So let me shift now. So this is minus Vm bar. This is VR bar. VRM bar will come in this way. Same length of vector. We'll take it. (30°). VRM bar will come somewhere like this. Sir, how that orientation, what is the speed? I think rather than fighting here, so better take unit vectors. So this can I write it as this as minus VRMX I cap that component, no, and we know this triangle VRMX will be there, VRMY will be here. So VRM is here. Angle with vertical usually, or we'll go for with horizontal. So this led with theta. Now we'll define tan theta. VRMY by VRMX.
Sir,
VRM by
V bar R is equal to 10 cos 30 I cap minus 10 sin 30 J cap.
what I did. Correct, no? 10 sin
Correct only,
30.
sir.
Correct.
Okay,
only.
sir. Correct answer. Sorry.
VRM by 5 root 3 by 2 by 5 root 3 by 2. Cos 35 root 3, huh? Okay, I'll change it. Yeah, fine. Okay, root 3. Tan root 3, it will be 60 degrees. How we should write umbrella? This will be very troublesome for student. I'm showing complete description. How the person should write umbrella. The rain is coming from behind, no? Is walking like that. The rain is coming from the behind. Here, its rain is coming from behind and is walking like this. Now you should write umbrella and the VRM bar. VRM bar is making angle 60 degree with horizontal, 30 degree with vertical. So that vertical is what I'll bring it here. This is the VRM bar. Then you should hold umbrella. Many students here is what, sir, like how it is possible, the rain coming from behind and you are telling like you should hold umbrella like this. So this is don't you feel it's a little bit funny? Funny in the sense like rain coming from behind. Just keep his umbrella against that. Over, finish against the rain. No, he's moving. So when it's moving, you have to keep the umbrella against VRM bar. The VRM bar is coming now in the front. If he keeps like this, then his front, everything will be drenched. Sir, I think, sir, maybe, sir, okay, he's protecting from the front. The completely back will be wet. No. Nothing. No, he's protecting. So provided this umbrella again should be sufficient size. Maybe the raindrops here will come and wet him. Please do practically. We're just discussing some small idea here. Size of umbrellas are very small umbrella. No, nobody can do anything. The umbrella, the dome should be of certain radius. If the height of the man is say some around say like a 1.4 meter, then if the dome is of only 1 centimeter, very small umbrella, in toys shop will be there, no? How do we can protect? It should be of sufficient size, no? At least half of his height. Yes, he can protect up to till here. Maybe its legs may be better. Please, all of you do understand. We are not discussing practical. Just a small idea to learn the relative motion here. Then don't blame me, sir. You only said to avoid wetting. Yeah, I should hold umbrella like this when raining. But sir, my lower part of the body got wet. How you thought all these things? So look at the practically here. The raindrops will come and strike you. Maybe your complete back part will be dry. The relative velocity will see that you will not be wet in the back. The complete this part will be wet. Please do have some practical analysis. They'll be better. So this angle, the angle what we got is this is what I'll write 60 degrees. Now if he stops running, so is the person, what is the state? Person at rest. This I'll write nearby, so it's at least you'll get an idea. Person moving. If he is at rest, again what he should do, he should rotate the umbrella and he should do it against VR bar. VR bar will not change direction. I think you start running, the velocity of rain will change. I think, are you so powerful? Nothing, no. So don't change this one. If it changes naturally, okay, but in general it will not change. Now with what speed he should run so that he can hold umbrella vertically? Can we calculate that speed further? Okay, I'll give one more problem. It will be very easy for you. Okay, then now we can shift these things. The page you can see clearly. Yeah. Hope everyone, I'm trying my level best to give it in a very simplified way through the diagram. Just you have to follow that vector diagram here. So don't do mathematics with this. You can do by cosine rule. Instead, I suggest you go for unit vectors. Take help of maximum unit vectors. It will be much easier. Define that VR bar. You can do by cosine rule. In the books they are given. So definitely the content that given is long back. Before vectors or happen, they used to think about cosine rule, everything. After unit vectors came, we stopped using cosine rule, sine rule, because the vectors will help us a lot. In books they have shown the old method by cosine rule, sine rule, they've solved it. Better take help of unit vectors and analyze. It'll be much easier. The speed of the raindrops, as you just take the vector of this, the magnitude of this. This will be -5 whole square, 25 plus 3. I think 10 meters. When he is at rest, with what speed the raindrops will come and strike? 10 meters. So when he is moving also 10 meters. How it is possible? The conditions are like that. Try to see. So what we should call this speed of raindrop with respect to man. Means with this speed the raindrops will come and strike the umbrella. Hope everyone is able to manage. So nothing big we are dealing here. Same situation. So let me create. Now what is the condition? What should be the velocity of man so that he should hold umbrella vertically? The condition, because I'll be more comfortable. What should be the speed of man? I'll describe the question here. The rain is pouring with a speed 10 meter per second at an angle 30 degree with vertical as shown. Find the speed of man, or find the velocity of man, will I find the velocity of man so that he should hold umbrella to avoid wetting. Okay, now a condition given for us. I should hold umbrella. So how the what do you mean by this? How the raindrop should come and strike? They should come and strike the VRM bar should be vertical. I think this is the condition it was given. Earlier we were finding out VRM bar. Now VRM bar direction is known for us. VRM bar should be vertical. We know other side VR bar. What is VR bar? Okay, let's get into calculation. VR bar equal to 10 sine 30 degree I cap no. Okay, look at this. 5 I cap minus 5 root 3 J cap. Phi I cap minus phi root 3 J cap. No, this is the velocity of actual velocity. What should be the velocity of man so that he should hold umbrella? So let's get into some mathematics here. As such numericals, you must take help of maths. There nothing is there for me. VRM bar equal to VR bar minus VRM bar. So what is this? This has to be minus J cap, no? So why you are writing minus J cap only? Look at the VRM bar. It must directed vertically down. VR bar we know, other side phi I cap in this situation. What shall I do now? Definitely what happened, the VRM, the x component of VRM should be 0, no? Because there's no x component, so I'll equate x components. So from there, so here we don't have x component, so therefore here equating x components of velocities. On both sides, so 0 equal to 5 minus Vm. If he runs with 5 meter per second, you have to hold umbrella vertically up. If he runs with 10 meter per second, you should hold umbrella in this way. If he runs with a speed less than 5 meter, then he should start tilting his umbrella back. So like we are not understanding. So you do one thing. This will be the best diagram you have here. VR is a constant, no? You decrease the length of this vector, then VRM can be vertical. Able to make it out. It is all about this, like instead of this length, this arrow keep it there only. This base here, this length you decrease it. Then this VRM will come here. by changing this length of this vector, what you can do? You can change the orientation of VRM bar. For VRM to be vertical, yes, bring VRM here. Got it? It's all about the triangle. I want everyone to put effort in the triangle. This is very important for us. Any conceptual question you can analyze here. Numerical, take unit vectors. So the method is, what you mean to say is like a VR bar is this is minus V bar, this VR bar. The VRM bar has to be directed in this way. Look at now. Possible, no? So you may get questions of these kind also. It's not that it's something straight away. Any doubts you can clarify? We'll go for paper discussion. Huh?
Sir, because VRM bar is vertical, so its x component is 0, sir.
Yeah.
Okay, sir.
Now, which raindrops is like, sir? There are two raindrops, are there? Black color, red color. Which raindrops? There are no two raindrops. This is raining. When you move, the rain appears in the direction. Sir, you tell me, sir, raindrops. There are two things are there. Like there, don't think that there are two raindrops are there. This raindrop, when it's moving, this will come. When it's at rest, this raindrop will come. When it's moving, this will no. The rain is falling like this only. When you move, the same raindrops will come and strike you vertically. Sir, how raindrops will change their direction with respect to ground? They don't change. VRM bar will change. I think this is something at least you have to digest this part. So these raindrops will come and strike him. No. If it's moving now with a 5 meter per second, the raindrops will appear. So if you hold something like this, you'll be safe. This you can try when you are raining and moving on a bike. You can experiment these things. We'll go for paper discussion. I'll end up the class, then I'll again continue. Okay, thank you all of you.